Hello everyone. This video is brought to you by Newton's Group of Institutions. I am Arvind Egireddy from the Department of CSE. In this video, I'll be talking about algorithms. If you like my videos, please subscribe to my channel and press the bell icon to get the latest updates. Now, let us see the definition of an algorithm. An algorithm is a finite set of instructions to accomplish a particular task in a given problem. Before writing a program for solving a problem, it is better to write step-by-step procedure for solving it. So this step-by-step procedure is called as an algorithm. In simple terms, we can say that an algorithm is a step-by-step procedure for performing some task in a finite amount of time. Now, let us see the criteria for an algorithm. Algorithm has the following characteristics: input, output, finiteness, definiteness, and effectiveness. Coming to input, for every program, input is essential. Sometimes it need not be. Here, input means the data supplied for the program. Hence, there should be 0 or more data items to be externally supplied to the algorithm. Coming to the output, the aim of the program is to get an output. Output is nothing but processed information. At least one output data item should be produced by a given algorithm. And coming to the fitness, every algorithm must terminate at a particular point. Here, a program should be solved within some number of steps. In all the cases, an algorithm must reach to the ending statement in a finite number of steps. Coming to the definiteness, each step of the algorithm must be precisely and unambiguously stated. So there should be no ambiguity for the steps specified in the algorithm. And effectiveness talks about a set of specified in an algorithm must be solvable. That is, each step in an algorithm must be solvable. The algorithm and flowcharts includes the following 3 types of control structures. First one is sequence. In the sequence structure, statements are placed one after the other and the execution takes place starting from up to down. And the second one is branching. Here branching means selection. So in branch control structures, there is a condition and according to a condition, a decision of either true or false is achieved. In the case of true, one of the 2 branches is explored, but in the case of false condition, the other alternative is taken. Generally, the if-then is used to represent the branch control state. Now coming to the loops, the third one, here whenever we need to repeat the same step, then we call them as loops. Here, the loop or repetition allows the statements to be executed repeatedly based on certain loop conditions. Here, the looping conditions are generally used by using while and for loops. Now let us see the advantages of algorithm. There are several advantages by using these algorithms, and it helps us, the programmers and the viewers, in many ways by writing the algorithms first. So it is a stepwise representation of a solution to the given problem, which makes it easy to understand. And an algorithm uses a definite procedure. And here, it is not dependent on any programming language. So it is easy to understand for everyone, even without programming knowledge. And every step in an algorithm has its own logical sequence. So it is easy to debug. Now let us see how to write an algorithm. So we can write an algorithm by using several steps. So whenever an algorithm is a set of steps, designed to solve a problem or to accomplish a particular task. And algorithms are generally written in a pseudocode or a combination of your speaking language in advance of writing a program. So here, first we need to determine the outcome of our code. So we need to identify what is the specified problem we want to solve or the task we want to accomplish. Once we have a solid idea of what we are aiming to accomplish, then we can determine the steps in which it will take to get there. And the second step, we need to decide on a starting point. Here, finding our starting and ending points are crucial to listing the steps of the process. So, to determine a starting point, we need to determine the answers to these questions. What data or input are available? Where is the data located? What informations are applicable to the issues at hand? What are the rules to the working with available data? And how do the data values relate to each other? Then we need to find the ending point of the algorithm. So as with the starting point, we can find the ending point of our algorithm by basically focusing on these questions. What fact will be learned from the process? What changes from the start to the end? What will be added or no longer exist? So by asking these questions, we can find the end point of an algorithm. Then we need to list the steps from start to finish. For this, we need to start with the broad steps. Now let us use a real world example. Let us say our goal is to have a pizza for dinner. Here, we have to determine that the starting point is to find the recipe, and that the end result is that we will have a fully cooked pizza which is ready to eat by 7 p.m. So here our steps may look like this. First of all, we need to search for a recipe online. Then look for the ingredients we are already having in the kitchen. Then we need to make a list of ingredients we need to get from the store. And then we need to buy the missing ingredients. And then we need to return to the home. And we need to prepare the pizza. And we need to remove the pizza from the oven. So these are the steps what we need to follow for the list of steps from start to finish. Then we need to determine how we will accomplish each step. So now that we are having a step-by-step outline, so it's a time to think about how we might code each step. Which language we will use, what resources are available, what is the most efficient way to accomplish each step in that language, how to incorporate some of the code in our algorithm, and how to expand each step until we have details the entire process. So for example, the first step in the pizza algorithm is search for the recipe online. So to do this first step, we need to turn on the computer. Then we need to check to make sure that we have a connected to internet, and we need to open the web browser. Then we need to enter the search terms, then click the recipe link, and we need to determine whether the recipe meets our requirements or not. Then we need to repeat these steps until we find that we have found the right recipe. So in this way, we need to determine for each and every step. Then what we need to do is we need to review the algorithm. So now that we have the written our algorithm, it's a time to evaluate the process where our algorithm is designed to accomplish something which is specific. And we need to start with writing our program. So finally, what we need to do is we need to ask ourselves some questions and address each as necessary. So does the algorithm solve the problem? Does it have the clarity defining the inputs and outputs? Should the end go good, or we need to be redefined, or can any of the steps be simplified, or is the algorithm guaranteed to the end with the current results? Then let us see an algorithm to find the average of n numbers. So to find the average of n numbers, I have written an algorithm with 12 steps. So here in this algorithm, we can see that it is terminating after some time. So which explains the property of finiteness. And action of each step is precisely defined. So in this particular example, each step requires simple operations such as reading, assigning, comparing, printing, and so on. So this explains the features of definiteness and effectiveness. And the total number of entries and their values will be the input of the algorithm, whereas the average of the entered values will be the output. So here from this we can say formally an algorithm can be defined as an ordered sequence of well-defined and effective operations that when executed will always produce a result and eventually terminate in a finite amount of time. Thank you. Thank you one and all.